Welcome back to the channel. Today, we're diving into route filtering using prefix lists. If you're learning EIGRP, OSPF, redistribution, or you just want tighter control over what routes your router advertise, prefix lists are a must-know skill. They're cleaner, more scalable, and more precise than access lists. Let's break it down the same way we always do: simple, visual, and to the point. So first, what exactly is a prefix list? A prefix list is a flexible way to permit or deny specific routes based on their network and mask. Think of them like a smarter, simpler version of ACLs specifically built for route filtering. Instead of matching just the network, prefix lists let you match the subnet mask ranges, and even control how specific or broad a prefix can be. They're basically a precision filter for routing protocols. Why would you want to use prefix lists instead of ACLs? First, they're cleaner. The rules are easy to read and even easier to organize. Second, prefix lists are more powerful. You can filter based on network and mask length, which ACLs can't do. And lastly, they're scalable. In real networks, filtering dozens or hundreds of prefixes is much easier with sequence numbers and organized prefix rules. So, if you want better control over what routes leave or enter your router, prefix lists are the go-to tool. So how do we exactly use prefix lists? First, we create the prefix list itself. This is where we define which routes we want to permit and which ones we want to deny. Then, we apply the prefix list under the routing protocol using a distribute list. The key point is this: prefix lists don't do anything by themselves. They only matter when applied to a routing protocol in direction either inbound or outbound. And once attached, the router will only advertise or accept the routes that match your list. Before we go any further, let's lock in a few terms you'll see in prefix lists. Sequence numbers. These control the order your prefix list matches routes. The router reads them top to bottom. Permit and deny. Same idea as ACLs. Prefix and mask. The network you want to match and how specific the mask must be. GE, greater than or equal to this mask. LE, less than or equal to this mask. And finally, implicit deny. Anything not matched by your permit statements is automatically denied. Knowing these terms make the whole topic much easier. Let's look at the commands. On the left, we're creating a prefix list. This is where we permit the network we want and deny everything else. On the right, we're applying that prefix list inside EIGRP. As always, create the filter first, then attach it to the routing protocol. These are the core commands you'll use almost every time you filter with prefix lists. Now let's break down what those parts actually mean. The prefix list name is just a label for your filter. It could be anything. Sequence numbers determine the order of evaluation. Lower numbers get checked first. The permit line allows the specific prefix you want to advertise. The deny line blocks everything else. This is your explicit catch-all. Then, the distribute list command ties the prefix list to the routing protocol and direction. This is where the filtering actually takes effect. So each piece has a purpose, and together they give you full control over which routes leave or enter your router. Here's a simple example. In this network, R1 has 3 networks, but we only want R3 to learn about the 192.168.10.0/24 network. So on R2, we create a prefix list that permits only 192.168.10.0/24. Then we deny everything else. Finally, we apply the prefix list outbound on the interface facing R3. The results: R3 only sees the route we want it to see, nothing extra. This is the power of prefix lists. Let's recap what we covered. Prefix lists give you precise control over route filtering. They're cleaner and more flexible than ACLs. Sequence numbers keep everything organized. You permit what you need, deny what you don't, and the rest is handled by the implicit deny. And by using distribute lists, you decide which routes get advertised or accepted. Prefix lists are one of the most important filtering tools in real networks, and now you know exactly how they work.